Hey everyone, it's Justin again. In this lesson, we get to solve rational inequalities. With inequalities, rather than just getting one solution, or maybe a few solutions for x, we'll get an infinite number of solutions. By the end of this lesson, you should be able to solve rational inequalities. Up until now, we've been working with rational equations, so we'll begin by discussing the difference between solving an equation and an inequality. Next, we'll discuss steps to solve a rational inequality. And finally, we'll complete two examples. Let's start with how the solutions differ between equations and inequalities. This is an equation that we solved in a previous lesson. We got only one solution, and it was x equals -3. With equations, we might get one solution like in this problem, or maybe even a few solutions, or potentially none. But with inequalities, we get an infinite number of solutions. Here's the solution to this problem. A solution like this has infinitely many numbers in it. While -1 is not a solution to this, +1 is in the solution set. And so is -0.007. And 0.0003 and 0.0213670004. We could spend forever listing all the numbers that fall in this part of the solution without even thinking about this part of it, because there are so many numbers to cover. And as a matter of fact, the number of solutions between any two real numbers that aren't equal is infinite. I know this might seem hard to wrap your head around, but it's true. That's what's so cool about inequalities. So now that we know what our solutions are going to look like, let's look at the steps we can use to help us get there. When solving inequalities, we may have to alter the inequality to make it look a certain way. That's step number 1. By this, we mean that there should be a 0 on the right side of the inequality and only one fraction on the left side. We have the skills to make our inequalities look this way from earlier in the unit. Our second step is to factor to find boundary points. These would be our boundaries of the intervals where the values of x satisfy the inequality. Our factors in the numerator will help us determine boundary points that will either be included or not based on the original inequality. And the factors in the denominator will help us determine boundary points that are not included. Then, we'll use a number line to test points within each of the boundaries we created in step 2. For this step, we need to remember that two negatives multiply and divide to be positive. Our last step is to write the final solution. Although you may have experience writing your solutions in other forms, we're going to be using inequality symbols to write our solutions in this lesson. We're going to use these steps to solve two practice problems together. If you need time now to go back through these steps and finish your notes, pause the video here. Also, remember to pause any time throughout the lesson that you need to. This is our first example. So let's solve this inequality for x. Our first step says to alter the inequality if need be. So do we have 0 on the right side of the inequality? Yes. And do we have only one fraction on the left side? Yes, we do. So step 1 has already been done for us. Now we can move on to step 2, which says to factor to find all boundary points. So pause the video here and factor the numerator and the denominator. This step also reminds us of what to do with the boundary points that we get from these factors. So let's set each factor in the numerator equal to 0. If x plus 1 equals 0, then x equals -1. And if x minus 7 equals 0, then x equals 7. These numbers would make the numerator equal 0, and therefore the entire fraction would equal 0. So these numbers can be either included or not included in our solution, and that's based on our original inequality. If the inequality has the equal to symbol in it, then these numbers are included and will be represented by a closed circle on a number line. Our inequality is less than or equal to, so since it includes equal to, we'll represent -1 and 7 with closed circles on the number line to show that they are included in our solution. Then we look at the denominator. Any numbers that would make the denominator equal 0 cannot be included in the solution because, well, the denominator can't be 0. We can't divide by 0. So if we set this factor equal to 0, it gives us that -3 cannot be in the solution. And this factor gives us that +3 cannot be a solution either. These are going to be represented by open circles on the number line to show that they are not included in the solution. Now that we have finished step 2, we can move on to step 3, which says to use the number line to test points. During this step, it's important to remember that two negative numbers multiply to be a positive number, and also divide to be a positive number. We'll need to test a number from each of these 5 sections that were created by our boundary points. The great thing about this step is that we aren't really looking to calculate anything exact, but just decide if our output would be positive or negative. So let's just choose a number from this section of our number line. We could choose -4.7, -10.32. There are infinitely many options here, but it's best to pick something easy. So let's just use -5. -5 plus 1 is -4. Don't worry about the 4 part. We just need to know that it gave us a negative number. Substituting -5 in here would give us -5 minus 7, which is also negative. So let's keep going and do the same in the denominator. -5 plus 3 would still be a negative number, and so would -5 minus 3. So in the numerator, we have a negative number times another negative number, which is a positive number, and the same is true in the denominator. Positive number divided by another positive number will also be positive, so on our number line, we'll make note that this section with the numbers less than -3 gives us positive answers. This is the exact same process that we have to use for the remaining 4 sections of the number line. Why don't you pause the video here and try to finish this step by figuring out if each of these remaining sections contains positive or negative answers. All right, let's see. I think -2 would be a nice number to test in this section. -2 plus 1 is negative. -2 minus 7 is negative. -2 plus 3 is positive, and -2 minus 3 is negative. 2 negatives in the numerator multiply to make a positive number, and in the denominator, a positive and negative multiply to be negative. A positive number divided by a negative number is a negative number, so let's go to our number line and mark that the numbers between -3 and -1 will give us all negative answers. Here's a great time to go back in the video and make sure that you understand what we're doing here before we continue. If you didn't figure out the other 3 sections on your own earlier, why don't you try it again now that another section has been explained? Choosing a number between -1 and +3, like maybe the number 0, and substituting it into the factored fraction gives us a positive times a negative in the numerator divided by a positive times a negative in the denominator. When simplifying, this becomes a positive number. So all numbers in this section will give us positive answers. In the next section, we could choose a number between 3 and 7. We'd get a positive number times a negative number in the numerator, and a positive times another positive in the denominator. This will simplify to be a negative number. Then move on to the final section and substitute in any number larger than 7. This section will give us positive answers. All right, we're almost done. It's finally time for step 4. We get to write that final solution here. And for this step, we get to use inequality symbols. You may know of other ways to write the solution from previous units and math courses, but for now, we're going to stick to the inequality notation for this lesson. In order to decide which sections of the number line contain our answer, we have to look back at the problem. We wanted our answers to be less than or equal to 0. Well, numbers less than 0 are negative numbers, so that would be covered in these sections. But what about the numbers that make our fraction equal 0? Well, we already covered that by making these circles filled in earlier in the problem. We write our final answer with inequalities. Notice that the filled in circles became inequalities with equal to in them, and the ones with the open circles became inequalities without equal to in them. Since we had two sections on our number line that worked, we write or between them. This says that x is between -3 and -1, including -1, or x is between +3 and 7, including 7. Whew. Let's try our second example now. Remember that first step says to alter the inequality if need be. Part of this step is to get 0 on the right side of the inequality, so how do we do that? We would subtract 4 over x plus 5 to move it to the other side of the inequality. We also need to get only one fraction on the left side of the inequality, so how do we do that? Well, we learned how to subtract rational expressions earlier in this unit. So pause the video here, go back in your notes if you need to refresh your memory. Try to subtract the rational expressions on the left side of this inequality so that the two fractions become only one fraction. Our common denominator would be x plus 3 times x plus 5. So multiply the first fraction by x plus 5 over x plus 5, and the second fraction by x plus 3 over x plus 3. Simplify the numerators by distributing. Then subtract the second numerator from the first. And now we've just finished step 1. Now we can move on to step 2, factor to find boundary points. The denominator is already factored, so we just need to factor the numerator here. Pause now and factor the numerator yourself. Now that we have all of our factors, we can use them to find our boundary points. This step also reminds us of what to do with the boundary points that we get from these factors. So try to finish this step yourself. See if you can find our boundary points and plot them on a number line. Let's see how you did. We set each factor in the numerator equal to 0. If x plus 4 equals 0, then x equals -4. And if x minus 3 equals 0, then x equals 3. These numbers would make the numerator equal 0, and therefore the entire fraction would equal 0. So do we include these numbers in our solution? Not. If our inequality has the equal to symbol in it, then the numbers we just got from the numerator are included and will be represented by a closed circle on the number line. But our inequality is greater than and does not have the equal to symbol with it. So since it doesn't have that equal to, we're just going to represent -4 and 3 with open circles on the number line to show that they are not included in our solution. Then we look at the denominator. Any numbers that would make the denominator equal 0 cannot be included in the solution because, remember, we still can't divide by 0. So if we set x plus 3 equal to 0 and solve that, we get that -3 cannot be in the solution. And this factor tells us that -5 can't be a solution. These will be represented by open circles on the number line to show that they are not included. Now we can move on to step 3, which says to use the number line to test points. During this step, it's important to remember that two negative numbers multiply and divide to be a positive number. So we're going to need to test a number from each of these 5 sections that were created by our boundary points. Remember, all that we're doing here is figuring out if our answers would be positive or negative in each section. We don't need specific number answers. So pause the video here so you can choose a number from each of these sections and decide for yourself. Let's see how you did. We choose a number from this section of our number line. We could choose to use something like -7. Negative 7 plus 4 gives us a negative number. Negative 7 minus 3 also gives us a negative number. Negative 7 plus 3 is also negative, and so is negative 7 plus 5. Multiplying two negatives in the numerator gives us a positive number, and the same is true in the denominator. A positive number divided by another positive number will give us a positive answer. So let's make note of that on our number line. This is the exact same process we have to use for the remaining 4 sections of the number line. So pause the video here if you haven't checked these sections already and do it now. Let's see how it went. Negative 4.5 would be a pretty decent number to test in this section since all the numbers between negative 5 and negative 4 are decimals. Negative 4.5 plus 4 is negative. Negative 4.5 minus 3 is also negative. Negative 4.5 plus 3 is negative, and negative 4.5 plus 5 is positive. Two negatives in the numerator multiply to make a positive number, and in the denominator, a negative and positive multiply to be a negative. A positive number divided by a negative number is a negative number. So let's go to our number line and mark that the numbers between negative 5 and negative 4 will all give us negative solutions. Now we choose a number between negative 4 and negative 3, like perhaps negative 3.5, and we substitute it into the factored form to give us a positive times a negative in the numerator divided by a negative times a positive in the denominator. So in simplifying, this becomes a positive number, so all the numbers in this section will give us positive answers. In the next section, we would choose a number between negative 3 and positive 3, and any answer in this section will simplify to be a negative number. Then we move on to the final section and substitute in any number larger than 3. This section will give us positive answers. All right, we're almost done. It's time for step 4. We get to write the final solution. And for this step, we're going to use inequality symbols. You may know other ways to write the solution for previous units and math courses, but let's stick to the inequality notation for this lesson. In order to decide which sections of the number line contain our answers, we have to look back at the problem. We wanted our answers to be greater than 0. Well, numbers greater than 0 are positive numbers, so that would be covered in these sections. But what about the numbers that make our fractions equal 0? We don't want our answer to equal 0 this time because our inequality doesn't have equal to as part of it. We already covered that, though, by making these circles open earlier in the problem when we were using the factors from our numerator. So we just write our answer with inequalities. Notice that since we didn't have any filled circles, we don't have any inequalities with equal to in them. Since we had 3 sections on our number line that worked, we write or in between all of them. This says that x is between negative infinity and negative 5, or x is between negative 4 and negative 3, or x is between 3 and positive infinity. Remember, infinity always uses inequality symbols without the equal to part. You may already know some other ways to write a solution like this, and you're also going to work with other notations in future units. But for now, we're going to keep our answer written this way for this lesson. Now you can solve rational inequalities. Remember to follow the 4 steps, and that infinity is never next to symbols with equal to in them, because you can never actually equal infinity. See you next time. Hey.